I want to talk to you today about existential risk. The first slide I will show will depict some of the greatest catastrophes of the last century, so the squeamish among you might want to look away. This shows the net effect of the two world wars, the Stalinist purges, the Holocaust, the Rwandan genocide, the Spanish flu. As you can see, in statistical terms, they don't even show up. The total number of human lives that were lived on this planet hasn't really been much affected by even these worst disasters that we have experienced. If one wants to consider some event that would actually show up in a graph like this, we have to go back further, say to the Middle Ages, where something like the Black Death would have made a dent in this kind of population graph. But even that kind of catastrophe is not what I want to talk to you about today. Existential risk is something different. There's this philosopher here at Oxford who wrote a book back in 1984 called Reasons and Persons, and he had this simple thought experiment that helps bring out what is at stake here. He asked us to consider three different scenarios. So one is that nothing happens, there's peace, things continue as normal. Another is that there is a nuclear war that kills 99% of the world's existing population. And the third scenario is that there's a nuclear war that kills everybody. Now, if we are asked which one of these would we prefer, obviously we prefer A. And if we had to choose between B and C, we would say B is really horrible, but C is even worse. So the rank order here is pretty clear. A is better than B, which is better than C. But then Parfit asks us to consider a different question. Consider how big is the difference between these different scenarios. Now, if we ask how big the difference is in terms of the number of people that are killed, then it's clear that the difference between C and B is much smaller than the difference between B and A. The difference between A and B is about, in today's terms, almost 7 billion people, whereas the difference between B and C is just 1/100th of that, so 70 million people. However, it's a different question that is more relevant to our decision-making, which is how big is the difference in the badness of these three different scenarios? And here, the order is reversed. Parfit argues that the difference in how bad C is and how bad B is far greater than the difference in how bad B is and how bad A is. Because if C comes to pass, if 100% of everybody dies, then it's not just that there is a massive number of people who are killed, but it's also that the entire future is destroyed. If B occurs, by contrast, you might eventually climb back up, and you might have as many people living in the future as would have lived anyway. So this goes to the heart of why I think existential risk is a particularly important and relevant category to consider. Here is another way to bring it out. We can consider different types of catastrophe and draw two axes here. One on the y-axis here, the catastrophe scope, how many people are affected. It could range from a personal catastrophe, something that affects one person, up to a local, global, or a transgenerational or a pan-generational, something that affects not just the current existing people, but all generations to come. And on the other axis, we can plot severity, how badly affected is each affected person. So in the lower left corner here, we might have an imperceptible personal risk, like the loss of one here. It's a very small harm. I've suffered a lot of those harms in recent years. But, and then as we go up towards the right and up in the diagram, we get increasingly severe catastrophes, and we could delineate roughly a class of global catastrophic risks, which are ones that are at least global in scope and at least of endurable intensity. But up there in the upper right corner, we have the special category of existential risk. So an existential risk is one that would have crushing severity, which means death or something in the ballpark of being as bad as death, something that radically destroys the potential for a good life, like maybe severe permanent brain injury or lifetime imprisonment, that kind of thing. And pan-generational in scope, that is affecting all generations to come. So we can define an existential risk as one that threatens the premature extinction of Earth-originating intelligent life, or the permanent and drastic destruction of its potential for desirable future development. Let's consider the values that are at stake if we're discussing these kinds of risk. It's plausible that the Earth might, in a good case scenario, remain habitable for at least another 1 billion years. Suppose that 1 billion people could live sustainably on this planet for that period of time, and that a normal human life is, say, 100 years. That means that 10 to the power of 16 human lives of normal duration could be lived on this planet if we avoid existential catastrophe. That has the implication that the expected value, this is when you multiply the value with the probability, the expected value of reducing existential risk by a mere 1/1,000,000th of 1 percentage point. This is such a small reduction that it's unnoticeable, but reducing existential risk by a mere 1/1,000,000th of 1 percentage point is at least 100 times the value of 1,000,000 human lives. So if you're thinking about how to actually do some good in the world, then there are many things you could do. You could try to cure cancer or dig wells in Africa, but if you could reduce existential risk by a mere 1/1,000,000th of 1 percentage point, arguably, on this line of reasoning, it's worth more than 100 times the value of saving 1,000,000 human lives. So this is mind-boggling. Now, the values can get even bigger. If we really were to survive for a very long time, maybe we'll develop more advanced technologies. Maybe our descendants will one day colonize the galaxy and beyond. Maybe they can find different ways of implementing minds in computers and so forth. And if one runs some calculations there, using less conservative assumptions, a much, much larger number of possible lives could result in our future if everything goes well. This would make the expected value of reducing existential risk vastly greater than this estimate there. This suggests that one might simplify action that is motivated by altruistic concern. That is, if you really want to make the world better, insofar as you're acting to do that, you can simplify a decision problem by adopting this max-epoch rule, which is to maximize the probability of an okay outcome, where an okay outcome is any that avoids an existential catastrophe. Because any other good effects, and there are other good effects, like helping people here and now, even if it doesn't affect existential risk, but the expected value of those actions will be trivial compared to even the slightest reduction in existential risk on this line of argument. This is not reflected in the current priorities of academic research, where we see that human extinction is a rather neglected area. There is more research on zinc oxalate than there is on human extinction, more on snowboarding than there is on zinc oxalate, and much more on the dung beetle than there is on all of the others combined. I think we have this sense sometimes that it's too big, too important, and too enormous for really to sort of fall within the microscopic lens of academic research, perhaps. There might be other explanations as well, but there seems to be a disallocation of attention. Attention is not always directed to what is most deserving of attention and is most important. Now, maybe this could be defensible if the probability was so negligible that even though the values at stake would be enormous, if it just can't happen, then there would be no reason perhaps to worry about it. This doesn't seem to be so. It's difficult or impossible rigorously to assign a particular probability to the net level of existential risk, say in this century, but people who have looked at the question, who have written books or examined aspects of this, typically assign a substantial probability. We had a conference here a couple of years ago in Oxford where we brought together experts in different risk areas from around the world, and at the end of that we made an informal poll, and the median answer to how likely do you think it is that humanity will be extinct by the end of this century, among those group of experts, were 19%. So it's roughly in line with what other people have said who have written about this. Now, it might be more, it might be much less, but either way, it seems that we do not have any solid evidence that would enable us to assign, say, a less than a 1% chance of this happening in the next century. And of course, if we consider longer timescales, then the probability increases. Right? What we currently take to be the normal human condition is really a hugely anomalous condition. In space, like Earth is this very rare crumble, most of it is just vacuum, inhospitable to life, and in time, the modern human condition is very unusual on geological, evolutionary, even historical timescales. And the longer the period in the future we consider, the greater the chance that humanity will break out of this human condition, either downwards by going extinct or upwards by maybe developing into some kind of post-human condition. Now, what are the major existential risks? Well, we have only limited time here, so we can't go into all details, but there are different ways in which you could classify or carve up the spectrum of existential risk. Here is one way. Now, notice that human extinction is one kind of existential risk. It's not the only one. Remember that an existential risk was defined as one that threatened to destroy our entire future, including our potential for desirable development. So another type of existential risk would be permanent stagnation. Another would be flawed realization, where we do develop all of the technological capabilities that we could develop, but then we fail to use them for any worthwhile purpose. And you could also consider a fourth category where we sort of initially develop all the technologies and initially use them for good, but then something goes wrong. So it's worth bearing in mind that in addition to extinction, there are these other ways in which we could sort of permanently lock ourselves into some radically suboptimal state. And that might be in the ballpark of as bad as extinction. Now, there are other ways in which you can sort of carve up the spectrum of existential risk. You could begin to look at particular risks, maybe particular risks from technology. You could say, well, what about bioengineered weapons? What about nanotechnology? What about artificial intelligence? And that can be informative for certain purposes. I just want to highlight one type of risk here. In the interest of saving time, consider this model for how humanity behaves. We have a big urn of possible ideas, possible inventions, possible discoveries, and we put our hand in this idea by doing research and experimenting and being creative, and we pull out new ideas and try new things in the world. And so far, we've made many discoveries. We've invented many technologies, and none has killed us yet. Most of them seems to have been pretty good, like the white balls here, and some have been mixed. Nuclear weapons technology, for example, has been perhaps a dark shade of gray, but so far we have never extracted from this urn a black ball, say an invention such that it would, for example, make it possible for an individual to destroy humanity. Like suppose that nuclear weapons, which are quite destructive but really hard to make, you've got to have these highly enriched uranium or plutonium, these very difficult to get resources, big industrial facilities to make these. It's really hard. But before we had discovered nuclear weapons, how could you be sure that there wasn't a simpler way of doing that, like baking sand in the microwave oven or something like that just could make some destructive capability available? So obviously nuclear weapons don't work like that, but if we keep making these inventions, maybe eventually we will stumble on one of these black balls, a discovery that makes it easy to wield enormous destructive power, even for individuals with few resources. And once we've made a discovery, we don't currently seem to have the ability to undiscover it. We don't have any way of putting the ball back into the urn currently. So one class of existential risk is of this type, that because we have very weak global coordination, because we can't sort of uninvent things we have invented, if we keep pulling balls out, maybe eventually we will be unlucky and discover something really destructive there. So what I would suggest is that rather than thinking of sustainability as an ideal that involves some kind of stasis, that is, rather than aiming towards some kind of condition which is sustainable in the sense that we could then be in that condition for a very long time, we should perhaps think instead of a dynamic notion of sustainability, where the goal is to get onto a trajectory that is sustainable, a trajectory on which we continue to travel for a very long time or indefinitely. So to use a metaphor, consider a rocket that has been launched and it's now in midair. Now, suppose we want to make this rocket more sustainable. Well, what could you do? Well, one thing you could do is to, say, reduce the fuel consumption in the rocket so that it goes slower. And in that case, it could hover in the air for a bit longer. But in the end, it's going to crash down. The other thing we could do is to keep the engines roaring and maybe try to achieve escape velocity. And once we're out in say, space, then the rocket can go indefinitely. But in this second strategy, you would actually temporarily decrease sustainability, like you burn fuel at a faster rate, but in order then to be on a more sustainable trajectory. And it might be that humanity needs to think similarly in terms of some trajectory that might involve at some point taking more risks in the short term in order to reduce risk in the long term. This graph here suggests that one might think in terms of 3 different axes where we have, say, technology on one axis. We want more of that ultimately. Insight on another axis, we also want more of that. And coordination, we want to be able better to collaborate and cooperate. And ultimately, we want to have maybe the maximum of all of this. This is the way to realize humanity's potential in the long run. But that still leaves open the question of, in the short term, is it always better to have more technology or more coordination or more insight? Maybe you need to get more of one before you get more of the other. Maybe you need to have a certain level of global coordination before you invent, say, really powerful new weapons technologies or dangerous discoveries in synthetic biology or in nanotechnology or something like that. So you might now wonder, what can we actually do to reduce existential risk? And well, that's of course a topic for another day. But I think that even getting to the point where we start to seriously ask ourselves that question is an excellent way to start. Thank you.